Hello, welcome to this tutorial on the TRI menu. We'll start off by just having a quick look at the TRI menu itself. And the options that we have here are selecting a TRI file, loading a file, playing a file, going into the setup, creating images from the data, creating sequences of images from the data, showing the count rate trend graph, and also exporting the count rate list. Functions in the TRI menu can also be represented as toolbox icons, and we've got a small toolbox here consisting of the selecting the TRI file, loading the file, entering the play mode, creating a graph from the data, creating single images, and creating sequences of images. So using the toolboxes, we'll have a look at how we go about carrying out some of the functions. We'll start by opening a file, and I'm going to go and open a file called clock.sxy. Now the SXY extension is an extension that is used with the HRPCS photon counting system, and it's called the sequential XY format. Now the SXY format actually stores a list of XY coordinates and time frame markers, and from this one's able to reconstruct images from any given time domain within the image. So we'll just open this file. What we're now presented with is a little dialog box that gives us some statistics about the data. It gives us the file name, it gives us the XY dimensions, the length of the recording in seconds, and the rate at which the file was recorded at. Below that we have the image depth, and this is the depth that we'll reconstruct an image to, and I would recommend that we leave this on the default 16-bit format. And also we've got a date stamp that tells us when the file was recorded. So we'll now press OK, and what this has now done is to take that list of XY coordinates and recompose them to form an image, and what we see here is the image created from the phosphorescent decay associated with the hands of a analog style watch. What we can see is around the side of the watch we can see the time markers. That's the o'clock, 5 past, 10 past, and so on around the periphery of the watch face, and we can also see in this case here the minute hand, and as the minutes sweep past from the 1/4-2 position to the 10-2 position to the 5-2 position, we can see the amount of signal reducing as the phosphorescence decays. And then in the graph window to the right here we can see the actual decay associated with the phosphor itself. I'm now going to change the palette to a colour palette. And what we can see is a little bit more detail in the image, and around the face of the watch we've now got this circular ring which corresponds to the second hand sweeping around the face of the watch. We'll now have a look at the play mode, and we can do this by selecting the play mode from the toolbox icon. And what we can now do is to define what we call a visible time. This is the amount of the sequential XY format file that is displayed on the screen. And I'm going to change this to 10 seconds, and then we'll press the play button. And what we can see now is that we've got 10 seconds worth of data, and you can see that from the time that has been acquired with the second hand, and that is progressing around the watch face as time increments. We can change the visible time from 10 seconds to, in this case, 20 seconds, and then when we press the play button again we can now see we've got a 20-second time window that is being displayed. And obviously each time we increase the time, the amount of data increases in the image and it appears brighter. And I'll just go back to a short exposure of 5 seconds just to give you a better indication, and you can now see the time ticking away in 5-second increments. We can also specify the time. At the moment that's going at real time, but we could make it go faster. In this case I'll say 5 times faster, and we can now see that the second hand is moving around significantly more quickly. Okay, I'll now just close all of the images that we've got down again. As long as we have the dialog box open, the sequential XY file format file is present in the system memory, and at any time we can reconstruct that file by pressing the load entire file icon. That rebuilds the image just so that we can see what we have. Next thing we'll have a look at is the ability to create an image from the time data that we've acquired. So if I press the create image icon, we're then presented with a dialog box, and in this we are requested to enter a start time and an end time. Now if I have a start time as it is at the moment, this is of 0, and we select an end time of 10 seconds, what this will do when we press OK is to prompt us for a buffer to store the image into, and I'll select image buffer B, and we can now see that we've got 10 seconds worth of data. If I do this again, and this time select a start time of 10 seconds and an end time of 20 seconds, and again press OK and put the image into buffer C, we can now see that we've got the next 10 seconds worth of data as an image. So we can take this a little bit further now, and we can create a sequence of images. And what we'll do is we'll say a start time of 0, and we will have an image time, or this is the integration time associated with each image, of 10 seconds. And we know that we've got about 750 seconds worth of data, so I'll say for argument's sake we'll put in 70 images, and what this will now do is to create a sequence or a stack of images containing a number of frames, and we'll put this into image buffer D. I'll just zoom that out so that we can see it a little bit more clearly, and we can now see this is a sequence window, and there's two things that tell us this. First of all, the icon itself has now got little sprocket holes down the side of the button. This is indicating that it's a sequence of images as opposed to a standard image. And we also have play controls across the bottom of the image. So across the bottom we've got a slider bar which we can use to move backwards or forwards through the image. And if we go back to the first image in the sequence, we can see the first set of data, and we can then move on to the next image by pressing the white forward button, which progresses one frame. So each time I press this button, we're moving on to the next frame in the sequence. And similarly, if you want to, you can go backwards. So before we go too much further with this tutorial, I'm just going to tidy the screen up so that we can see a little bit more detail. We'll just delete all of the images that we have in the memory. And the easiest way of doing this is to go to Operations and say Zap All Images, at which point we're asked to confirm this, and this will just delete everything from the system memory. And what we'll also do is to just again reconstruct the file. Now the next thing that we're going to do is to have a look at some more of the time resolve capabilities of the system. So what I'm now going to do is to go to the toolbar menu, so I'll go to View menu, Toolboxes, and we will load an existing toolbox which is called, if I just scroll a little bit further down, OAS, which is Odd Area Sets, and we'll say Open, and I'll just put that in this position of the screen. Now what we can now do is to draw areas of interest onto this image, and we'll start by putting a circle down, and I'll just put a circle around one of the markers associated with the 20 past position, and we can, if we just press OK, the system will give it an automatic name, and it's called it OAP0. I'm going to put down another marker, and this time I'm going to put down a rectangular area just above the minute hand, and again that's going to give it an automatic name of OAP1. and we'll also put down another rectangular area. It doesn't really matter where it goes, we'll just put it in this position here, which is going to look at the seconds hand. So we've now got 3 areas that we're looking at, and what we can now do is to show the count rate trend graph, and that's this icon here, create count rate trend graph. And at the moment this graph here has been created using the single selection. However, if we say use odd area sets, use OAS, and again we'll just use everything on default binnings, and we press OK, we now have to select the image that we're interested in, which is going to be the clock face itself. And what this has done now is to go through this data and reconstruct the count rates in each of the areas that we've defined in the image. Now, the blue trace, which is odd area set 0, is just looking at the data associated with the 20 past marker. And what we can see is that this is just a static item, and we can see the exponential decay associated with the phosphorescence of the luminous marker. The red mark, which is the rectangular area that we place just above the minute hand, shows the minute hand passing through the rectangular area. And then finally we've got the green marker, and what this is the second hand passing through the odd area profile 2, and this is happening every 60 seconds. I'll just enlarge this up a little bit so that we can see the data in a little bit more detail. Now, as it stands at the moment, the data's been constructed every 10 seconds, so the resolution that we get associated with the information isn't very good. But what we can do is to go back into the count rate trend and change the bin size. Now at the moment it's on 10-second bins, and what we'll do is we'll turn the automatic bin size off and we'll change that to 1-second bins. And if we now go through this, what we can see now is that yes, the data is noisier, but we've got more detail and precision associated with the time response of the measurements. Okay, I'll just make the graph window a bit smaller again. But what we'll now do is to have a look at actually saving the data associated with the count rate trends that we've extracted. What we can now do is to say save data to file and press OK, and we're now requested to save a file with a file name. I'll just press save, and that should now have saved the data for us in the directory. So we'll now go into Excel, and I've done a file open, and we've got to the text import wizard, and what we can see here is the contents of the file, and I'll just show you some of the points that we're interested in. We've got the time, the odd area profile, 0, 1 and 2, and then we've got a list of comma separated values. So what we need to do is to select the data as delimited data. We will then change the delimiter to a comma, and we can now press next and finish. And what this has now done is to import the data into an Excel file. We've got the headings on line 7, and then the data timing in column A, and the counts in columns B, C and D. And what we can do, if we want to, we can select a region of the data. That'll do for now, and we can now say insert a scatter graph, and we can now see the data in a similar format to what we had in Image32 itself. It's worth noting that the count rate trend analysis is limited to 16 odd area sets, and sometimes it's useful to be able to analyse more areas than this. There is a workaround, and I'll show you how you can go about doing this. So what we'll do is we'll just close down the image. I'll just delete the image as well. We'll close the graph. Now what we need to do is to create a sequence of images, and that's using the create sequence icon, and we'll do that in exactly the same way that we did earlier in the demonstration, and we'll put the sequence into buffer A. And what we can now do is we can draw onto the area or onto the image areas that we're interested in, and we'll put a rectangular area in a similar position to before, and we'll put a area representing the second hand marker somewhere around there. And what we now need to do is to use the extract odd area set tool, and what we have to do now is to point to the actual image buffer itself, and then press the left mouse button, and that will generate a text file which gives us the statistical data associated with the areas that we've defined. Now what I've just noticed here is that the information that we've got is not giving us the correct statistical data that one would normally require, and that's because I've got an option in the measure menu set up incorrectly, and it's something that you may come across, so it's useful to be able to know how you go about correcting this. So we'll go to the measure options, we go to odd area sets, and what we need to do is to make sure that extract single data item only is selected. Now at the moment this is showing the mean intensity. What's more useful to do is to select the total intensity, which we can do like this, press OK, and if I now extract the data again, select the image buffer A again, what we now get the counts in each of the areas rather than the average count rate. We can now save the data by going to the file menu, selecting save, and we'll give this a name of we'll call it OAS, and this will be saved as a text file, and this has now been saved for you, and you can load this into Excel and analyse the data in any way that is suitable for your needs.